Comes on everyone. Let's start off. Let's see how to do this. See. Take a full sphere. So Q2 R2, right? So if you take a full sphere, this charge will be 2Q2. Radius is R2. So inside you are taking this guy, the half sphere, Q1, R1. So if you consider a full sphere, the field inside is 0. Therefore, the force would be 0. Agreed? If you take this half shell, inside this big full shell, it will be 0. So this is nothing but this half shell plus this half shell. Means the force between the left half and this piece, let's call it F1. And the force between the right half and this piece, let's also F1. They should be equal. Is this making sense? If you have taken a full sphere, the force on that half shell, the small half shell, would be 0. That means the force due to the left hemisphere and the force due to the right hemisphere of the big one should cancel out. So this is equal. Now take the small one and take this guy. Now between them, we already calculated there is a force, that is this guy 34A. Let's call it F dash, which is sigma 2 E pi R2. I'll just call it F dash. You can F dash, this we calculated in refer page 34. Page 34, page 110. So we calculated that F dash, isn't it? Now this is nothing but this plus this, isn't it? That means now if you look at this thing by symmetry, this and this, yeah, I think I wrote the same thing, no? I wrote the same thing, wait. This and this. Agreed? Now, if you look at by symmetry, this is F1. These two are same, no? And if you look at this thing, you're finding force on that, no? This would be F1. This also would be F1. Agreed? Because see, these two are looking same. These two are looking same. Is this making sense, everyone? So basically, if you see now by repulsion, if the big shell is pushing with this F1, this is being pushed this way F1. So they're pushing each other with F1 and F1. So here you can clearly see 2F1 will be equal to F dash. From there we get F1 is equal to F dash by 2.
So how can we say कि वो दोनों F1 ही होंगे?
Where, अरे, this is Newton's third law, ना रे.
No, I got that in a single diagram. लेकिन in the
ये
first
ठीक
diagram
है.
and the second diagram. नहीं ना.
Why?
So how can we say both F1?
Because see na, this is what is this F1? This F1 is a force between this half shell and this shell.
हाँ.
Agreed? By
Yes.
Newton's third law, but the small shell also will push this away by
No,
F1.
I got that, sir.
Hmm.
I am asking that in the first diagram and in the second diagram, उन दोनों में you have taken the forces as F1. Both the red forces. दोनों F1 क्यों लिए? F1 F2
Because
लेंगे तो F1 को push to.
this one you're saying?
हाँ, इन दोनों में we have taken F1 only. Why F1?
Because net force is zero.
Okay.
That's your
हाँ,
problem.
yes.
I thought you were asking
Got
something.
it.
Okay.
Got it. Got it.
So are you able to see the symmetry here? So if this is F1, by Newton's third law, this is F1. This is the force on left half due to right half. Getting it? So no, doesn't this look like this? And doesn't this look like this? The crisscross, no, they look same. That means here, when you kept this F1 and this F1 got cancelled, you got zero. But in this scenario, this F1 and this one are adding up and you're getting F dash, isn't it? Able to see the symmetry, everyone?
So, yeah.
So, and F dash to be calculated in this problem. Have a look at this. So it's more of a symmetry there. In the second diagram, if you split it like that, you want it to be bigger or pure overlap. Anika, is this clear? Still confused? No, if I combine these two, won't I get this? I'm taking basically a chota sphere ka force hai na? The force due to the small sphere on the big one is F dash. So I'm breaking the small sphere into two pieces. So each sphere ka force on the big sphere should be in the same direction, isn't it? The same direction. And from here we proved that both are equal. Only the left and right became reversed. Have a look at this. Still confused? Let me know. If there had been two half solid sphere, then the question is gone. That also we did in a way. Didn't we do this thing? Force between upper and lower hemisphere. You would have used this thing last time. Like. That is one. Next thing. Dipole. The bigger wala hemispheres would overlap. देखते हैं break में after the class. Let's see. So what's a dipole? Like I said, dipole is more of a mathematical concept. A dipole is a combination of two equal and opposite charge. With a distance d between them. So if you have charge minus q, we have charge plus q. And the distance between them is d. So this whole setup is called a dipole moment. And this symbol is, we represent the whole thing with something called a p bar, which is given by q into d bar. The vector goes from the negative to the positive charge. B bar is vector from negative to positive charge. And that's a convention. So anytime you see plus and minus with a distance d, you can replace this with a dipole. So this is called a dipole moment. Now in physics, this is a little rare to see, but we see this in chemistry a lot. So when you take an HCl molecule, we know because of that Cl has a more electronegativity, this thing will pull the electron cloud more towards it. You get slightly positive and slightly negative, creating a dipole. So if you take something like CCl4, I'm sure you studied this compound's dipole moment is 0. So in this case, if you see, this is one dipole, this is another dipole, this is another dipole, this is another dipole. Actually, the net dipole moment cancels out. So primarily what we're interested is, when you have these dipoles and stuff, how do these dipoles interact? So let's see that. So this is a straightforward formula. So dipole moment is P is equal to Q into D bar. So example, if someone gives me charges like this, 2Q, minus Q, and minus Q, then I can split this into plus Q, minus Q, plus Q, minus Q. So I can treat this as one dipole, I can treat this as one dipole. So I can make two dipoles like this. Let's say they're on equilateral triangle or something, 60 degrees. So I can say there are two dipoles with an angle of 30 and 30. So the net dipole moment is, so if you have multiple charges, you can somehow you have to create equal and opposite charges. 2p cos 30 j cap. So where p is equal to q into a, whatever is the distance between the charges. Clear? Direction is towards Ci. What is Ci, Aryan? Chlorine, meaning we are taking dipole is from negative to positive, isn't it? Chlorine will be delta minus and carbon will be delta plus. It is more electronegative, so electrons will go towards it. It becomes a negative charge.
केमिस्ट्री में उल्टा होता है कन्वेंशन.
Okay. ठीक है, end of the day they cancel out. That's the most important thing for us. Our convention, the vector bar, we take it like this, negative to positive. So forget about chemistry. You don't know anything about it. Let's see only physics. Now, suppose if I give like this, can you tell me what is the dipole moment of this system? Minus Q, 3Q, minus Q, 4 things on the sides of a square. What's the dipole moment of this system? So you can split this as, this is one dipole. Let's call it P1, which is Q into A. This is another dipole, which is P2, which is Q into root 2A. And this is another dipole, which is again P3, which is Q into A. There we have to take the vector resultant of these three. So that would be how much? QA, QA, and in this direction, It would be q a root 2. So 2 root 2a. Right? So this angle is 45, 45. You can take the components qa cos 45, qa cos 45 will give you qa root 2 in the direction of p2. You can directly add it up. So you can split the 3q into 3 minus q's. Sure? So we have a ring here. Let's say the right side is having positive charge plus q, and the left side is having a negative charge minus q. Find the dipole moment of this ring. Yeah, Saina. It is basically you take equal and opposite charges, no? So 3q has to have minus 3q. If you have unbalanced charges, then for example, if this had been 2q, right? Then I would take like this is one dipole, this is one dipole, and this is just a unit charge. So it is two dipoles and one single charge. Plus q. P, yeah, and minus q. If this had been 2q. Let's get this. Nay. Ishan, did you solve or you know the answer? If you know the answer, fine, but you should know how to do. How do we do this? No, Kush, that is not the answer. But why will you take Ishan? Do this thing, Ishan, अगर ऐसा लग रहा है तो do lambda is equal to lambda right sin थी. इसका dipole moment निकालो. Okay. Integrate. You can do that. What you guys are saying is true. But then Kush, even then you cooked up. Yeah, right, Lakshika. But direction भी देना. Yeah. Try. I'll give you a minute, everyone. You need to integrate, but I'll show you a nay, Kush. That's not the thing. Shell नहीं है, God, ring है. How do we take an element and integrate? Now, because if you don't integration, then they'll give you a question like that, lambda not sin theta or cos theta, and then you'll get trapped. So now there are two ways you can choose elements. Let's say from here, take a thin element like this. At an angle theta, take a d theta. So this guy would be plus lambda r d theta. This guy would be minus lambda r d theta. So we created a dipole dp, which is lambda r d theta into 2r. But if you remember, I told you always, whenever you integrate vectors, you integrate the component. So dp bar would be 2 lambda r square d theta cos theta I cap plus sin theta j cap. Now by symmetry, we can see they would cancel out, right? By symmetry, they would have cancelled out in which direction? Vertical direction, and only the horizontal components add out, but let's derive. So 2 lambda r square integral cos theta d theta I cap. Limits will be, now understand this point theta is 0. So if you complete theta is equal to 180, you will complete the whole upper hemisphere and the lower part will get covered. So theta goes only from 0 to pi. Because you're covering two elements at the same time, you need only 0 to 180. 0 to pi plus integral sine theta d theta j 0 to pi. That cos ka integral will become 0. Sine ka, no, cos ka will become actually horizontals cancel out, verticals add up, right? 2 lambda r square, that guy would be sine theta. So this is 0. This guy becomes minus cos theta, that becomes 2 j cap. So we get dipole moment is 4 lambda r square. But lambda is nothing but charge by unit length q by pi r into r square. So if you observe, we get a pretty interesting answer. Q into 4r by pi, which is actually q into 2 into the center of mass, y center of mass of the ring. That means this whole question you could have simply replaced. I think I goofed up somewhere. I goofed up. The limits are actually here. No, you're doing only up and bottom. My mistake. You're covering this way. Plus pi by 2 to minus pi by 2. Because yeah, right is positive, left is negative.
The difference क्या बनता है? Like you're covering the charges equally.
हाँ, but direction change हो जाएगा ना. यहाँ पे if you see ना dipole moment, actually if you see you can take elements like this also.
Oh, right.
I cap j cap का difference आएगा. If you take up and down, the dipole moment will be up. So minus pi by 2, pi by 2. Now j cap will be 0. Magnitude will come same. 2 lambda r square. This guy will become 2 I cap. Lambda is q by pi r square I cap. So you can see here this will be q into 2 into 2r by pi. So this side is plus. So the whole question comes as if you can replace the charge at plus q here at center of mass. And I hope everyone remembers the ring ka center of mass is 2r by pi. R by 2 nahi hai. And how many times center of mass came till here? Center of mass ka chapter. Then it came in rotational mechanics, moment of inertia. Then it came in fluid mechanics. Now it is coming. Bloody, it keeps popping up everywhere. Don't forget it. 2016 or 17. Center of mass of a solid cone. This was a mains question. बस इतना ही क्वेश्चन था स्ट्रेट फॉरवर्ड. डू यू गाइस रिमेंबर सेंटर ऑफ मास ऑफ सॉलिड कौन क्या था 3r by 7
No,
e power minus 22 h by 4. Right. So do remember the results. So this would be 2r by 5. So the whole system behaves as if there is a plus q and there is a minus q with a distance of 4r by 5. So clear? Now again, why does this work? The reason it works is because dipole moment, if you see p bar is q into d bar, it's d power 1 linear function. Isn't it? It looks like it's a linear function. So center of mass concept works. It's like if you look at the center of mass, m into x center of mass is nothing but what? Summation of mi, xi. So here also, you look at the dipole moment, you get something similar, sigma qi di, isn't it? So net dipole moment is nothing but sigma qi di bar. So this thing is also sigma mi ra bar. Mathematically, they look the same. So center of mass concept works. Meaning not only this, you give me any weird shape, as long as you know the center of mass, it works out. Meaning even if you have taken solid sphere, integration would be more tough. You have to take rings and then prove it, but anyone remember solid spherical center of mass? (3000 r by 7000 x). What is it? 3r by 10. I should punch you guys. Whoever got the wrong answer, punch yourself. 3r by 8. Center of mass of a solid sphere is 3r by 8. Hollow sphere is r by 2. So this is plus solid hemisphere.
हाँ सर भाई आप sphere
ठीक है ना, solid sphere तो 0 होगा ना, वो भी wrong बोल रहे लोग then.
अरे then तो उसके पीछे सकता है
So solid hemisphere, this guy would be 3r by 8 and 3r by 8. So there, you could have got the answer. Q into 3r by 4. Clear? So uniform charge distributions, you know the center of mass, it is easy to find. All got the integration? Any doubts on the integration, please ask. Now you could have chosen elements like this also. Huh? You could have taken like this element and this element, and you could have done this also. In this case, the distance will change, but you'll get the same answer. Let's see one more. You guys do for this thing. Lambda is equal to lambda naught sine theta. Now this is a non-uniform ring, so its center of mass we don't have an idea. Then if they give you something like this, you will get trapped. Linear charge density. Find dipole moment. Lambda naught is constant. That's the reason you should know integration. But if this is given in the exam, how can you guess the option? What will be the direction? That much you can guess.
Upward.
Vertical. Because sign, the entire up will be positive, bottom will be negative. So that much you can say it should be J cap. Yeah. Get the value, everyone. We have one answer, pi r square lambda. Okay. Try. Got a minute. Today's CET results came out. People scored 170s, 180s, 155. Last year, 150 marks was 99 percentile, it seems, in CET out of 200. Ranks आएगा 1-2 weeks में. Any other got an answer? Yeah, one answer. R square lambda not pi up. Okay. Yeah, looks So let's see. The same idea. Now this time I think my elements will be right now. Theta will go from 0 to pi, because the entire upper part is positive and the lower part is negative. And if you see the values also, this will be like small plus more, more, more. It will become more positive, and again it will become less positive. Same thing will happen on the bottom, negative, negative, more negative, more negative, 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 negative. Theta d theta lambda r d theta minus lambda r d theta. So I'll directly write it down. So dipole moment dp bar is lambda r d theta into 2r. The vector form is cos theta I cap plus sine theta j cap. But lambda itself is lambda naught. You will get cos theta. So cos square theta d theta I cap sine theta cos theta j cap. So integral cos square theta d theta I cap. This would be from 0 to pi. This would be sine theta cos theta j cap 0 to pi. That actually becomes sine 2 theta. That I think will be cos 2 theta. So this term will be 0. Yeah, that term will not be 0.
Lambda not sine theta or lambda not cos theta?
Sine theta na.
So sine square theta or sine theta.
Yeah, I coughed up. So this 5 will become sine 2 theta by 2. This will become sine square theta. This term would be 0. Sine square theta ka integration is what? 1 minus cos 2 theta by 2. That cos 2 theta will become 0. You'll be left out with pi by 2. So 2 lambda naught r square pi by 2 j cap. So lambda naught pi r square j cap. Yeah, pi lambda r square. Got this? Next thing.
Sir, how did you integrate sine square theta that quickly?
Do na, you'll get it. I did it manually, mentally. So 1 minus cos 2 theta by 2 na re. Cos 2 theta will become 0. सिर्फ बचेगा half.
Okay, समझा.
Next thing. Or think of like this thing now. What is the, let it be. You solve. That is only better. You will learn faster. Next thing. So now we have a dipole. So the primary thing about dipole, right? We like to find the field and potential. I will not do the derivation part. We'll just put it down. Field and potential due to dipole. Now, this thing, right? More than the formula is fine. The derivation is not really that important. The best thing is there's an approximation which I want you to learn. We're going to use this extensively in wave optics. So whenever you have a dipole here, P bar, and let's say from the center, pretty far somewhere here, let's call a point A here at an angle theta, and this is distance r. So if r is much, much greater than d, we have formulas for this. So basically this thing is nothing but minus q. I'm exaggerating the figure. So this is r. this is D. So if R is much greater than D, we can do a binomial approximation here, kind of extend the vector, extend this line theta. So you want to find this line, let's call this as point P only. Let's call this as point A, let's call this as point P. So this is what we do. So from here, we drop the perpendicular. Again, since it is so small, this distance will be D by 2. This also will be theta. This distance will be D by 2 cos theta. So we drop a perpendicular and we call this point A dash. So we will say AP is almost equal to A dash P, which is equal to R minus D by 2 cos theta. You getting the logic? Again, meaning the diagram would have actually looked like this. You won't even notice a difference. So you just extended, so you dropped it. It would have been like this. When you say R is much greater than D, we are talking something like 100 times more. Getting it? So here I'm exaggerating the figure. So that's a approximation. R minus D by 2 cos theta. Similarly, when you take this guy, you want to find BP. Let's call this BP. So we will drop a perpendicular like this. So this distance also will be D by 2 cos theta. So we write BP is approximately B dash P. I wrote reverse actually. R plus D by 2 cos theta. And this is R minus D by 2 cos theta. Let me just magnify that thing and see. So what you're doing is this. Plus Q minus Q. This was the line. So when you're dropping the perpendicular like this distance is D by 2 cos theta. And you're calling this point as A dash. When you're dropping the perpendicular, this point you're calling B dash, and this distance is also D by 2 cos theta. So from the center, the distance is R. So for B dash, it will be R minus D by 2 cos theta. For A dash, it is R plus D by 2 cos theta. Is this clear? We can do this because R is much greater than D. So this is valid since R is much greater than D. If you ask me, this is the most important thing. At least for wave optics, we're going to use this approximation a lot. When it comes again, I'll show you, but I'll show you why we're doing this. Basically, I want to find the potential. Now, potential ke liye, what is this formula? KQ by AP and KQ by BP, right? But it is not that easy to find this distance directly, na? This is R, this is theta, this is D by 2. I have to use cosine rule to find this distance BP. We can find, but it will be like complex. All clear with the approximation? So getting back to this again. So plus Q minus Q. So this is point P, this distance is R. This is A, this is B. So potential at point P is K Q by BP minus K minus Q by AP. We can use the binomial the approximation which we have seen. So this will be KQ by R minus D by 2 cos theta minus KQ by R plus D by 2 cos theta. Cross multiply, take out KQ common. It will be R plus D by 2 cos theta, R minus D by 2 cos theta. We end up with D cos theta. Denominator, we get R square minus D square by 4 cos square theta. We can neglect this term since R is much greater than D. So we end up with potential as K P cos theta by R square. This is a potential due to a dipole at a distance R, where R is the distance from the center. And here theta is the angle, like this. Theta angle is from plus to negative. There we got the potential. Then we have to use a differentiation in polar coordinate differentiation. So this is actually minus dou v by dou r e r cap minus dou v by r dou theta e theta cap. It's a three-dimensional thing, so let's not worry about it. So there is something like this. So when we do this, we end up with a field. The result is more important. I'll show you in the next page. 2 kp cos theta by r cube e r cap plus kp sin theta by r cube e theta cap. E theta cap is tangential direction. Just like I cap and j cap, these are polar coordinates, polar differentiation. We don't have in the portion, so don't worry about it. This is the radial direction. So primarily we are doing this in order to find the field and potential due to this small dipole. And from there, eventually I'll tell you, our final goal is to find a force between two dipoles, so dipole-dipole interactions, which you studied in chemistry. That's where we're trying to reach, but before that we need to find the field due to one dipole. Yeah. So there, the final result, I'll put it down. That's the most important thing. So whenever you have a dipole, P bar, at a point P, the electric field will be 2 kp cos theta by r cube. This is the radial field away from the center. This would be kp sin theta by r cube. This is the tangential field. And the direction would be in this thing. So theta should be rotated in that direction. This r is the distance between the P and the center. So this formula is valid only when r is much, much greater than d. And potential at point P is simply kp cos theta by r square. You need to mug up these results. Similar results you'll encounter again in magnetism. And if you take the net magnetic field, since they're anyway perpendicular, you can square them and add them. That would be sine square theta plus 4 cos square theta. You end up with kp by r cube common root over 1 plus 3 cos square theta. Anyway, that's not that important. Have a look at this. So we found a field due to a dipole at this thing at a point P. Case 1, if you take theta is equal to 0 degrees, meaning you're talking on this line. So this is called the axial line. Basically, the point P is somewhere along the dipole. So in this scenario, theta is 0, so there'll be no tangential field. The field only will be in this direction, which is 2 kp by r cube. Case 2, if you take theta is equal to 90 degrees, means you're talking along the perpendicular bisector. Questions were asked on this directly in mains and CET, right? In this case, the direction would be this way. You can think about it, obviously, plus q is pushing this way, minus q is attracting this way, so the field has to be anti-parallel to the dipole moment. This is kp by r cube. So if you look at a CET level, they only ask case 1 and case 2. They don't even ask this general formula. So this is especially useful to find that field and potential due to that very small charge. The plus q and minus q are pretty close. If you try to actually do with calculations, you will get the same answer, but it will be complex. So we are ideally, what we're doing is we're doing the approximation in the beginning and then we are solving. You need to copy this down, put it down. We are going to do problems based on this, so note it down. It's a small thing. We should wrap up today. We will start off with Gauss law introduction also today. Put it on, put it on. Clear? Can I go ahead? Let's see our question. We have a small dipole here, P, right, which is actually constructed from Q is equal to, let's say, 10 power minus 6 coulomb, and D is equal to 2 millimeters. It is along the J direction. The center is at the origin. So from here, there's a point A. The arrowhead is positive, the tail is negative charge. 3 comma root 3. Find the field and potential at point A. When I say field, vector form.
E bar, you have to find the net magnitude or entire
E
I
bar, vector, I cap, J cap. Just you can get the form and leave it in I cap, J cap, so you can resolve. That's okay. Hmm. Let's see. So first of all, what is P bar? Q into D. The Q is 10 power minus 6. D is 2 mm. There is 2 into 10 power minus 9. And if you look at this angle here, so we are talking about this angle. That would be tan theta. This is 3 and that is root 3. So this angle is 60 degrees, isn't it? And this distance r will be how much? Root over 3 square plus root 3, that is root 12 to root 3, that is your arca value. So here, this is the radial direction, which is 2 kp cos theta by r cube. And this is your tangential direction. So you rotate the angle from plus towards minus. This is kp sine theta by r cube. You know all the values. K ka value is 9 into 10 power 9. So the 10 power 9 goes off there. Correct? And cos 60 is this. So this is 2. K is 10, 9 into 10 power 9. P is 2 into 10 power minus 9. And r cube you can calculate. That's 2 root 3 whole cube. And that's cos 60. There, you'll get the values like this. Then you can resolve them into I cap, J cap again and finish it off. So this angle would be again how much? 60, 30. So this would be 30 and this would be 60. There, you can take I cap, J cap. It's a little lengthy, but you'll get the answer. And potential is simply kp cos theta by r square. Check. Clear? So be careful with the theta especially. Theta is an angle which is from plus to minus. So tangential in this scenario would be in this way. Theta is from head towards tail. Clear? Next one. So we have a dipole at the origin. Find the locus of all points. Where electric field is along y-axis. Meaning there should be only j component, there's no I component. How do we do this? So if you consider a point here, so you're saying the field should be in the horizontal direction. That means the vertical direction. So horizontal should cancel out. If this is theta, this is theta, this is 90 minus theta. And let this coordinates be x comma y. So 2 kp cos theta by r cube का cos theta should be kp sin theta by r cube का sin theta. We get tan square theta is equal to 2. Tan theta is plus or minus root 2. This is nothing but y by x. So basically we have two lines like this. So this line and this line. Any point on this line, the field will be in the vertical direction. One is I cap and one is minus j cap. Minus j cap and plus j cap. Clear? Basically two straight lines. So any point on that line will have a horizontal component 0. And that's your locus. Next thing. Next thing. Dipole in a uniform electric field. So if you take a dipole and if you place it in a uniform electric field E at an angle theta, so this is plus Q, this is minus Q. Basically it forms a couple. This guy would be EQ. This would be EQ. Remember, for a negative charge, the force will be opposite to the field. This would be the perpendicular distance d by 2 sine theta. So torque about the center is equal to EQ d by 2 sine theta 2 times. So torque will be E into QD into sine theta. And Q into D is nothing but PE sine theta. So in the vector form, you can simply write torque is equal to P bar cross E bar. Do remember this. Like I said, whatever I'm teaching you today, literally everything will repeat in magnetism exactly same. E का place में will have magnetic field, P का place में will have magnetic moment. This is your torque. Remember, valid only for uniform field. Same way, you can see work done by internal conservative forces. Is minus change in potential energy. So work done is nothing but torque d theta minus delta U. So delta U integral torque is PE sine theta, T theta, theta 1 to theta 2. That will give you cos theta minus cos theta. Limits will go from theta 1 to theta 2. P cos theta 2 minus cos theta 1. Now we can choose something as reference. We choose theta 1. So basically this is u theta 2. Sine का integration is but it is actually work done by external force. Let me show you the next page. I'll show you. You are rotating from theta 1 to theta 2. I'll do one thing, wait. Basically, someone took a dipole at P1, making an angle theta 1, and they rotated it to theta 2. So we want to find the work done. So here, if we choose theta 1 as 90 degrees as reference, so u of 90 is 0. You end up with u of theta 2 is minus PE cos theta 2. So this is the potential energy formula, minus P bar dot E bar. There, this is the second formula which we can remember. So what do you mean by this reference exactly? If this is the electric field, if you take a dipole like this P bar, when both are 90, you're taking this as a reference. So you're choosing here the potential energy is 0. Like I keep saying every time, whenever you say potential energy, you need to define a reference. If P bar and D bar are in the same direction, potential energy is negative maximum. This is stable equilibrium. Torque is 0 because both are parallel. This is stable equilibrium. Suppose if P bar and E bar are in the opposite direction, torque is still 0, but this time the potential energy is plus P. This is an unstable equilibrium. Even a little disturbance, it will rotate. Whereas in the first case, theta 0, it would oscillate at SHM for small theta. Didn't we do this in the beginning? Remember which question? This guy. It was the same question. They got torque, we got the same thing. Torque is equal to I alpha. For small angles, it actually was in SHM. If theta was small, that sine theta becomes approximately theta, and we could have solved it. Mainly, these are the two formulas. Torque is P cross E, and the potential energy is minus P dot E bar. Clear? So exam a simple question would be like this. So a dipole is making an angle of 30 degrees. E bar This is P bar and this is 30 degrees. So the question would be, find work done by external force to rotate the dipole 30 degrees anti-clockwise. What would be the answer? Theta 0, stable equilibrium. See na, torque is 0. What is the stable equilibrium? Torque should be 0 and potential energy should be minimum. Yeah, minus P. And you can clearly see here also, if you try to disturb this, what will happen? The E will come back now. The P will always try to be in the direction of E. Right, Saina?
Sir,
Ishan,
in the
remember this, you
previous
are
page,
asking this only.
yes, I answered. In the previous page, you have taken theta 1 equal to as reference लिया है, तो then theta 2 will be theta 2 minus theta 1 now, because we
No, theta 1 and theta 2 are the angles from the electric field.
but then if you took it as reference, then u theta 2 should be, मतलब वो जो angle घुमाया उतने में होना चाहिए ना?
No, theta 2 is the final angle. I didn't say you rotated theta. I said you went from theta 1 to theta 2.
Okay.
There is a difference, na? Here, what is the final angle?
60 degrees.
60 degrees, na? Got it? So, what is
Yes,
initial
yes.
potential energy? So, initial potential energy is minus PE cos 30, where theta is the angle between P bar and D bar. U final is minus PE cos 60. Got it, everyone?
Oh, yes, got it.
And work done by external forces change in potential energy since you're rotating it slowly. Have a look at this. Clear, everyone? Udian, clear with this? Vartika? Yasha? Rehan? Great. Let's see. Next one is the main question. We have a dipole here, P1. We have another dipole here, P2. The center to center. This distance is R. R is very large. Again, compared to the length of the dipole. Find force between the dipoles and the potential energy of the system. So if these two are interacting, there'll be some potential energy. This will be a proper advanced question. Give it a try 1 or 2 minutes, then I'll show you this, and then I'll ask you B part that you can also try on your own. But first, you give it a try for 2 minutes. How will you find the force between two dipoles? So technically, what is happening? I'll tell you. See, there's a charge Q1, there is a minus Q1, there is a minus Q2, and there is a Q2. All four of them are interacting with each other, isn't it? So they will generate some forces, they'll generate some potential energy. All that we know is a dipole moment Q1 and Q2, P1 and P2. We don't know the charges, we don't know the distance between them. Think, how will we proceed? But 1 unit negative can only interact with 1 unit positive. Who said? Arey, that is the definition of dipole moment is one positive, one negative. Interaction का नहीं है. Interaction, any charge can interact with anything else, isn't it? Meaning the moment you use plus q and minus q for one pair, the dipole is done. You shouldn't use that for second dipole. Actually, if you get the force, potential energy भी आ जाएगा. Or vice versa. Q1, D1, Q2, D2, and brute force. वो बहुत लंबा हो जाएगा ऐसा. That will be long. We have to use that approximation. No? That's useful. P1, P square root P1. See, listen, I'll help you with one. You guys try the second one. There are two ways to do this. One is little more brute force, but there is one very technical way of doing it. It's pretty nice. It's quite useful. You're going to use it in multiple places. Let's say this is P1 bar. The other dipole, let the charge be minus Q. And let the other charge be plus Q. And let the distance between them be dr. So basically P2 bar is nothing but Q into dr. Okay? Now, due to this dipole, at this point, let the field be E and let the field be E plus D. Because you're going little more, we always assume functions are increasing. Let field be E at minus Q. Again, due to whom? Let field be E due to P1 bar at minus Q. E plus D, the signs will take care of it. D will come negative at plus Q. Fair enough. So the force on the second dipole would be Q into E plus D minus Q into E. So QE, QE will cancel. You'll end up with Q into D. Clear? Now, so the force would be, if I multiply dr here and dE by dr here, this guy becomes a dipole P2 and this becomes dE by dr. But we know the field due to a dipole on the axial line, because it's on the axial line, is 2 kb by r cube. So if you differentiate this dE by dr, you end up with minus 6 kp by r power 4. Substitute here. The force between them will be minus 6k P1, P2. This guy is the P1 ka dipole by r power 4. There. The minus indicates the force is attractive. So dipole-dipole interactions are 1 power 4. I'll write this in the next page. Indicates attractive. This is a technique we can use, quite useful. Another way to do is this. Actually, it's the same thing, but it's a little brute force. We'll do like this. This is P1 bar. So this is minus Q. This is plus Q. From here to here, this distance is R. So this distance will be how much? R minus D by 2. This distance will be R plus D by 2. So we will say force is equal to field, which is how much? 2 kp by R plus D by 2 whole cube into Q. minus 2 kpq by r minus d by 2 into whole cube. Same thing. Then we do binomial approximation and solve it. We would end up with the same answer. So instead of making 4 charges and doing the brute force, na Ishan, you can choose as one as dipole. Due to the dipole, find the force on the 2-point charges and then add them up.
Okay, sir.
All clear with this? Energy कैसा आएगा? I can actually use the same logic for potential also. Why can we differentiate here? Because what we got here is d by dr, na? I just multiplied dr, so it became d by dr there. Basically, the net force is because of that small change in electric field, isn't it? If the field was uniform, the net force would have been 0. How to find potential? There are 2 ways again. Minus q plus q. You can say here the potential is V, here the potential is P plus dV. Again, same 0, the potential energy would be potential Q V plus dV minus QV. So we get Q dV. So this would be Q into dr and dV by dr. That guy becomes dipole P2. And we know potential on the actual line is Kp by r square, Kp cos theta by this thing. And then differentiate dV by dr. Minus 2 Kp by r cube. This is the potential energy between the 2 dipoles, meaning these 2 dipoles are actually attracting each other. So in order to separate them, you need to provide them this much energy. Or you could have done like this also. F is equal to minus du by dr, remember? And you already know the force value, 6k p1 p2 by r power 4 is equal to minus du by dr, and integrate them. Clear? Limits will go from r to infinity. Because at infinity, you're taking potential energy 0. That also would have worked. But this technique is pretty nice, huh? Taking at a distance E, dE, and differential, that will save you a lot of time. You can use binomial also. That also works. All clear with this? So can you tell me for this guy then, if this is P1 bar, this is P2 bar, both are perpendicular. Now find the force and energy between them. So you can have parallel dipoles, you can have perpendicular dipoles. Force 0 नहीं record. Force 0 नहीं है. Energy 0 है. Same technique. Try it, I'll give you a minute more. Just to give an idea, what will I do? See, don't take P1 here. Huh? That's a bad idea. Why? P1 ka field here will be this way and this way. This field will be this way, this way. That is more complex to study. This time, choose P2 as reference. And let this guy be plus Q and minus Q. because then this will be an axial line, the bisector line for P2. So this would be E and this would be E plus DE. Isn't that how the field will look? For P2, this is the perpendicular bisector, where field is given by Kp sine theta by r cube. Theta is 90. Kp by r cube. So if you do that thing, same thing you'll get F is equal to Q into DE. This is
the
Q
field is in
into.
opposite direction, no? E plus F minus F.
नहीं रे, देखो ना, this is plus ना, it will push this way. This is minus, it will attract this way. So field is down only ना, opposite to P bar.
हाँ तो ऑन द माइनस पे तो उल्टा, अच्छा फोर्स उल्टा होगा.
Force उल्टा होगा ना. So this will be Q D dr, dE by dr. This direction would be upward, J cap. Force will be upward. So differentiate this. So dE by dr would end up with 3K P1 P2 by R power 4. And you'll get a minus J. The force is actually down. Because actually DE is negative. As you go away from the center, field decreases. So plus Q ka force will dominate. dE by dr becomes negative. Clear? And what about the potential? Potential on the axial line is 0. Bisector, na? It's an equipotential plane, 0 potential. Therefore, the potential energy is 0. Means you need not do 0 work to separate them to infinity. So let me put down everything in the next page. So you can remember this, quite a useful result. So if you have two dipoles like this P1, the force between them would be minus 6K P1 P2 by R power 4. The potential energy is minus 2K P1 P2 by R cube. Suppose the same dipoles were like this. In this case, they would be repulsive. The force would be plus. You can just put P2 as minus 1, so you would have got the same thing anyway, plus. In this case, they're repulsive. This is attractive. So in this case, the force would be 3K P1 P2 by R power 4. Potential is anyway 0. By changing the orientation, the force will be up or down depending on it. Clear? So the question is especially important, the force is proportional to 1 by R power 4. And the energy is proportional to 1 by R cube. It's a pretty rare formula with 1 by R power 4. R power 4 we saw. We never saw 1 by R power 4. This question I still remember 2018 or 17 something. I was teaching in the class on Sunday class, and that day was advanced exam, and that day this came the question. Paragraph question tha. They gave some this thing here, and they said they asked relate the relations karke. 1 by R cube, 1 by R square, 1 by R power 4 and everything. Clear? Take a break, come back with 7.5. Any doubts so far? Aryan, you're saying something? Oh, shell ka? हाँ.
सर उसका जो सेकंड पार्ट लिया वो बड़ा वाला शेल नहीं आएगा ना उसमें.
No. What I was trying to do now, the force due to the small shell on the big shell, right, is equal to the force due to this right half on the big one, the left half on the big one, isn't it? दोनों pieces का force on the big one is the sum is the force due to this inner shell due to this thing, ना?
हाँ. पर सर वो नॉर्मल रिएक्शंस तो अलग होगा ना, मतलब
किसका?
दो अलग बॉडीज है ना, तो
ये?
हाँ। नहीं, वो दोनों जब कंबाइन करेंगे तो बड़े वाले का
हाँ,
तो डबल
दोनों
आएगा ना।
कंबाइन करेंगे। नहीं रे, नहीं नहीं सर। अरे गॉड, if there is a B and there is a A and there is C, if A is exerting force on this F1, C is exerting force on F2, what is the net force on B? F1 plus F2 ना?
F1 + F2।
तो वही तो कर रहे हो ना? The force between this guy and the big one is F1, the force between the small guy and this guy is F2. So
ओके।
what is the force on this outer one? F1 plus F2, right?
F1 + F2, यस।
वो टू टाइम्स ऐड नहीं करेंगे हम। डोंट थिंक लाइक यू आर मिक्सिंग देम।
हाँ हाँ हाँ, ओके।
मिक्स नहीं कर रहे हैं।
गॉट इट।
चलो, कम बैक इन 5 minutes. हाँ विद्युत, दिस पेज ओनली। Chal, comes on everyone. So try this as a homework. Next class we'll be discussing this. This is a good one. We have a ring here plus q radius r. On the axial line, at a distance of r root 3, you kept a small dipole at an angle theta. Find the force, torque on the dipole, and potential energy of the system. Meaning here the system is dipole and the ring. It's a good question, Ray. Do try this as a homework. Give it a try. Next class, first thing in the class, we'll be discussing this. This is a good advanced level question. Whatever techniques, whatever we used in this thing, dipole, everything will come in magnetism. It becomes quite easy there. Idea is the same. P becomes M and E becomes B. This is a good one. Give it a try. Clear? You are eating noodles. Cup noodles. Cup noodles only? No. It is a staple food actually. We used to get cup noodles for 7 rupees.
But it tastes so bad.
Yeah, depends on what you're getting. In morning 3 o'clock, what do you get to eat? There. That's about electrostatics. We have done 55 questions. So do make sure to try everything again. And you can start solving that. So next part is Gauss law. Gauss law is one chapter, right? You ask me, it is tough, not because the numericals are tough or something, but there's a lot of symmetries. You have to really visualize a lot of things. It's a good chapter though. Quite an interesting one. Let's see. So the first thing is electric flux. The symbol is phi. So it is defined as flux is proportional to number of lines passing through an area. That means let's say 5 lines are passing like this. 5 lines are passing like this. 6 lines are passing out and 1 line is passing in. I don't care how big is the area. I don't care how they are going. All have same flux. Simple definition. Flux is what? Number of lines passing through an area. How big area, what angle, we are not interested. So fundamentally, this is what flux means. Number of lines that cross that area is called, it's proportional to flux. Now, if you try to put it in a mathematical form, the flux is given by integral E bar dot dA bar. E bar is the electric field. A bar is the area vector. And if E bar is constant, then the flux becomes E bar dot A bar. That means if this is area vector and if this is the field vector, an angle theta. So use E dot A only if it is constant. Now there is a problem. Just now I said something and it looks like I'm contradicting already. Just now I said I don't care about the area, don't care about the angle. And suddenly I'm saying flux depends on the area and cos theta. What is the catch?
It is electric field and they are field lines.
Yeah, if you remember the definition of electric field, remember electric field is number of lines per unit area. Isn't it? The electric field intensity is number of lines per unit area, unit cross-sectional area. So that is anyway perpendicular thing. So that area and this area will cancel out. So what you're left is number of lines, isn't it? So if you study in terms of lines, it doesn't depend on area and angle. If you study in terms of electric field, it depends on area and angle. So it depends on how you are trying to study it. So in terms of lines, I don't care. It is simply number of lines. But in terms of electric field, area and angle would matter. So this is your main formula there, integral E dot dA. So we'll be playing with that today. We will see the applications of this exactly. Where do we use this later on? Any doubts on this page? Maulika? Swastika? Clear with this? Ali? Adrit? Anika? No. If we study in terms of number of lines, right? It doesn't depend on flux, doesn't depend on area and angle. If we study in terms of field, flux depends. Now here the main thing, when we keep saying area vector, how do you define an area vector? If you remember, perpendicular, there is more. In vectors, I taught you this for the first time. If you remember, for closed figures, we take the outward normals as positive. You guys remember? Vectors में किया था ये. Long back, I'm sure you must have forgotten. Area is a vector quantity. For closed figures, outward normals are positive. For closed figures, we choose the outward normals are positive. Just a convention. Right? And if you have open surfaces, you can choose anything. But generally, we choose in the direction of E bar. Whichever side E bar is there, we try to take in that direction. It should be perpendicular. So So if you give me something like this, so I will choose A bar this way. If E bar is this way, basically I try to keep the angle acute. And there is nothing like that. You could have chosen anything. There, straightforward. So what is flux? E dot dA. If E is variable, we have to integrate. If E is constant, then it is fine. Clear, everyone? Oh, 4 people got disconnected suddenly. Anyone from Anshakti Nagar? I think generally this happens to Anshakti Nagar people. All go off at the same time. It's like they're going on a strike. Internet कुछ problem हो गया रे. Their entire internet shuts down at the same time, na, normally. Something happened or power must have gone. ठीक है. Let's see one question in the meantime. This is your X, this is your Z, and this is your Y. This is your origin. It's a cube of side A. So there are 6 surfaces. Phase 1, phase 2, phase 3, phase 4, phase 5, and phase 6 is behind. Find flux through each phase. Case 1, the field is E is equal to E naught I cap. Field is equal to E naught xi cap. 3 different questions. Field is E naught xi cap, E naught yj cap, E naught zk cap. Sure. What happened, Ray? Mostly suddenly 4-5 people got disconnected. You all tried to boycott the class. ऐसा कुछ है? Strike.
I guess same network issues.
ऐसा कुछ हुआ होगा. कभी ट्राई किया आईआईटी में बॉयकॉट करने के लिए क्लासेस? Professor will simply fail all of them for that semester. You just repeat next year again. Full dictatorship पे भाई पे कुछ नहीं चलता है. Let me get this thing. Only ना movies में होता है. Hero goes and does all nonsense in front of the professor, and college people are like fools. They're dancing around. Real life में they'll suspend him. There we have a cube of side A. So there are 6 faces. 1, 2, 3, 4, 5, 6. I want flux through each face. You know, a square. नहीं, Aryan, sign भी important है. Remember E dot A, area vector का accordingly it will be plus or minus. If E is in the direction of, it's a closed figure, right? So area vectors are defined properly. For closed figures, we take the outward normals as positive. All 3 done, sir. E naught I cap, E naught xi cap, E naught xi cap, y cap, j cap. There are 3 questions.
डन सर मतलब आपने जब पिछला पेज दिखाया था वो लिख
Oh, उसका done. ठीक है. First one, what to do? I'll show you one. See the first one. This is the cube. How is the area vector? This is the area vector. This is the area vector. Area vector, area vector, area vector, and area vector. How is the field? E naught, I cap. So this is E naught. This is E naught. This is E naught. This is E naught. Perpendicular basically. This is E naught. And this is E naught. Isn't it? So flux on 1 will be minus E naught A square. Remember, it's a scalar quantity, but there's a plus and minus sign. Plus E naught A square. The remaining 4 guys are perpendicular, so all are 0. Since E is perpendicular to A bar. Easy? And if you see the total flux will be 0. Kind of makes sense because think about it. The number of lines entering the box are number of lines leaving the box. And the flux is defined as total number of lines. If entry is equal to exit, then total should be 0. Can you do B and C? Now try. I'll give you a minute. I want flux on each face, 1, 2, 3, 4, 5, 6, not the full cube. Now, if the field is E naught x I cap, meaning the field is changing with x coordinate, it's not constant. Push, right.
Sir, 5 is the front wala face, no?
5 is the front.
Then I sent you the answer.
Let's see. This is for the B part, even though there's an E naught x I cap, you need to understand. Now, on the face 1, E is 0. Why? X is 0. On face 2, E is E naught A, and the area is there. So flux on 2 will be E naught A cube. Now, I agree. On the remaining ones, the field is changing, but I don't care because it's perpendicular. At every section, the field is different. Technically, you should integrate. But luckily, on each part, everywhere it is perpendicular. So here, flux 1 is 0. Since E is 0, the reason is different here. Flux 2 is E naught A cube. The remaining will be still 0 because E is perpendicular, even though E is variable. So there's no need to integrate actually. Clear? The last one, Lakshika. Yeah, that looks right. What about C part? So B and C are actually same. I just changed the orientations. Look at the third one. The third one, what we will do now, flux 1, flux 2, 3, 4, because it's a scalar quantity, you can directly add it up. So due to the E naught x I cap, I can do to each one. This guy is 0. This guy is E naught a cube. This guy is 0, 0, 0, 0. Due to E naught y j cap. So if you see the diagram, E naught y j cap meaning the field is in this direction, means only 3 will have flux, isn't it? So this guy will be there and remaining all will be 0. Similarly, E naught z k cap. So z meaning it is coming out here. So 5 will have flux and remaining all will be 0. Easy. So just like the way you did for E naught x, you do it for j and k separately and just add them up. So 146 will be 0. Easy. And here there's no need to integrate. Next one. We have a hollow hemisphere. Radius r. And we have a uniform field. Find the flux passing through the curved surface. Yeah. Can I say E into 2 pi r square? The problem is, look at this thing. At every instant here, this is your area vector. Your field is like this. Did you see? None of them have same angles. So E is fine, dA is fine, but the theta is different here. Theta is variable. So if you try to calculate the flux, it will be integral E dA cos theta. So you can't write flux is not equal to E into 2 pi r square. You can't do this because the angle is changing. But then we know something. Every line that enters this curve, that same line will pass through this. And if you remember the basic definition, as long as the number of lines pass through, I don't care what is the surface area. We can use projected area. So flux into E into projected area. So in this case, simply it is E into pi r square. Since the number of lines passing through the curve is equal to number of lines passing through the disk. There, this is the third time you're saying. Fluid mechanics, surface tension is projected length, and this is again projected area. So if you put a more general format, let's say if I take a disk like this, you go and give any random surface. This is your projected area. Only issue, field should be constant. Field is variable, you're dead. Flux is E into projected area. Valid only if E bar is constant. Clear with this? So don't write E into 2 pi r square. Be careful with that. So we are using the basic fundamental thing that the number of lines is what is actually proportional to flux. Clear? Next one. Next one.
So in the previous question, if the field is changing in the vertical direction and not in the horizontal direction.
Field is changing in the vertical direction.
Yes. Only in the
Okay.
vertical direction.
Then still you'll have flux.
Now, what I'm asking is, can we still use projected area concept? Or we can,
नहीं.
or let's do something else.
अरे तो सोचो ना, if E is changing मतलब your field lines are going like this, right? Meaning there are some lines which won't pass through the disk.
अच्छा, okay.
तो नहीं कर पाएंगे.
Yes, sir. Okay.
So we have a disk here. We have a charge Q here. This is an angle theta. Disk का radius is R. Find the flux passing through the disk due to the point charge. The field is not uniform. Huh? You can't use any projected area here. It will be minus E into pi r square. Yeah, you're right. It will be E into minus pi r square. Because then if you say all the angles are obtuse here, actually. The flux is entering, no? Flux is not coming out of this thing. You're right, Swastik. It will be negative. Let's get this. It's a good one. There are two ways you can do this. One is brute force integration. Actually, another is also integration, but yeah. Let's see. You try, I'll give you 2 minutes. Figure it out. It's quite a good result. You have to remember this. Helps a lot. This result, what we're deriving now, will again come in modern physics. There, the question will be like this. Here, there is a bulb with power P, number of photons passing through the disk. Try.
What is the distance between them?
Can't you find out? Answer भी दे दूं? You can find out. देखो. Hmm. Yeah, I didn't teach you Gauss law yet, but yeah, you can use solid angle actually.
I don't know solid angle.
I'll teach you.
So is that answer correct, the one which I sent you?
थीटा में कन्वर्ट कर लेना रे उसका, बट x क्या है उसमें कुछ,
So वो distance लिया था मैंने, उसको x ले लिया।
तो सब्स्टिट्यूट करो ना,
हाँ,
you know the distance, right? See, first thing, brute force. At a distance x from center, take a thin ring. Radius x, thickness dx. So from this point charge, the field is going like this, E. And for this guy, the area vector dA is going like this. So if I take this angle as alpha, this angle is alpha. So the small flux on the ring is field into area into cos theta, cos alpha. So this distance, whatever it is, you can take it as x. That is already took it as x now. Let this be some d. So field will be k, q. The diagonal distance is root over r square plus d square. So that is x square plus d square. And the area would be 2 pi x dx. And cos alpha would be there. So here you can write tan alpha is equal to x by d. Dx is equal to d secant square alpha. Substitute. So d5 would be kq 2 pi x is d tan alpha and dx is d secant square alpha cos alpha d alpha, and denominator mein you have d square 1 plus tan square alpha, तो secant square alpha. Secant square d square goes off. Tan alpha is sin alpha by cos alpha, so you will be left out with kq 2 pi sin alpha d alpha. So the total flux through the disk will be k is 1 by 4 epsilon. So that is q by 2 epsilon integral sin alpha d alpha. Alpha ka value goes from 0 to theta. Q by 2 epsilon 1 minus cos theta. Quite a useful result to remember. Definitely mark up this result. Q by 2 epsilon 1 minus cos theta. It is independent of the distance and independent of the radius. You will see why. Because end of the day, what matters is number of lines. Please check out the integration. This is like brute force. The reason why I'm teaching you like this is for some reason, if it is not a point charge but something else and the field is not changing as 1 by r square, then the game will be different. Whatever is the reason, if the field is somewhat a little weird. Clear? Now, alternate way. This is a good one. Right? Think of like this. The disk which is here, if I take this part, this is charge Q. Can I say like this? Every line that passes through the disk will pass through the curve. This thing is a part of a sphere. Isn't it? So basically, flux through the disk will be equal to flux through that curved surface area. Since number of lines are same. That means, so this was a part of a sphere, and this point charge q was at the center. That's what we are treating it as. If something is at the center, then you're done actually. So if at any instant, if you see this is the field, and from the center area vector is also this thing. So E bar is parallel to dA bar at every point, because both are passing through the normal, right? Therefore, the flux will be integral E bar dot dA. This becomes integral mod E mod dA, and that would be cos 0. The flux would be magnitude of E comes out. This will be integral dA. So field due to point charge is how much? Kq by r square. And what is the area of that part surface? 2 by r square, 1 minus cos theta. Do you guys remember this? The area of a part of a sphere. I hope you remember that. We did multiple times already. I think we saw that in calculus May. I told you to remember this result. Surface area of a part of a sphere, 2 pi r square, 1 minus cos theta. Quite a useful result. We saw this thing, calculus May I taught you. Then the first time you encountered this in friction. Where is that? Dust is sprinkled on a sphere. Find the area covered in dust. The next time you encountered in ray optics. The bulb has the power P. Find the area escaping from the surface. This is your third time you're saying. You'll see again in modern physics. So K is 1 by 4 pi epsilon. So you'll end up with Q by 2 epsilon, 1 minus cos theta. This is what I was saying. Whenever you learn something, right, try to relate it to as many chapters as possible. That way, you will remember very well. You'll be able to connect between different chapters. And you won't find physics overwhelming. It'll be more fun. The problem is when you think every concept is different and you think everything alag-alag se you have to learn, you'll feel like it is getting overwhelming. And if you see, whenever I teach you, this is one thing I keep telling you. As long as the equations look same, maths don't care. Certain things like these things are the main things. Do check out this integration. Clear with this? Let's see a question. So we have a charge Q1, we have a charge minus Q2. So one of the field line leaves Q1 and enters Q2 at an angle alpha and enters at an angle beta. One of the field line, there are multiple. A field line leaves at angle alpha and enters minus Q2 at angle beta. Meaning, even though it is hypothetical, if you actually try to plot, you will see something like this. Find relation between alpha and beta. I'll show. Here. Here. Let's get this. Hmm. नहीं ईशान. That's you're close by. Lakshika, you got it. Now, basically, you have to use the previous result. See, if you don't know the previous result, this question is gone. So, idea here is Q1 and Q2. So, when this line is entering, symmetrically, there'll be one more line on the other side. So, what we are choosing is we will take a thin disk exactly in front of it. They'll take one disk in front of it. So, we can argue every line that passes through this disk has to go through this. Isn't it? So we will take a disk, which is the edge of the line. So this is the last line here, and this is the last line entering here. We can choose a disk such that every line that enters, right, will be there, and you're taking the disks very close to it. Because the flux is independent of the distance. So for this disk, right, the angle is alpha, and for this last disk, this angle is beta. So the flux should be same. Flux through the disks must be same since the number of lines is same. That's what I'm saying. That first thing we should learn, the number of lines is same. We keep playing with that only. Therefore, flux 1 should be equal to flux 2. Again, we're taking magnitude. Q1 by 2 epsilon 1 minus cos alpha. It looks easy because you know the result. Q2 by 2 epsilon 1 minus cos beta. There you can simplify further. Clear? Next one. We have a sphere here of radius r. We kept a point charge q somewhere here, not at the center. Find the flux passing through the sphere. I know some of you know Gauss laws, but I didn't teach you Gauss laws. So how will you prove that? And do you even know why, the Gauss law, why it works? That way. Think. Take a minute.
I read in HCV, but then I forgot.
ठीक है ना, एग्जाम में वो नहीं लिख सकते ना. I read an HCV, I forgot, so please give me at least 2 marks. You guys are still fine. Imagine you being a doctor, you say this. अरे ऑपरेशन थिएटर में, अरे भाई बुक में पढ़ा था, व्हाट शुड आई कट? कट दिस आर्टरी और कट दैट आर्टरी, मतलब. Then you say, let's Google it out. Patient is there, body cut enough, and you're there searching in Google how to operate on heart. Guide for dummies on heart surgery. Q by epsilon. Did you guys prove it without using Gauss law? The thing, the reason why we use Gauss law is because Gauss law actually came before Coulomb's law. Kidding? And Gauss law came before Coulomb's law, and it is specifically useful for this. Coulomb's law is more powerful. Now, see, I'll tell you how we can argue this thing. First, consider, let's say there's a point charge Q. Consider a sphere where Q is at the center. I know that is not as given, but let's see. Then on the sphere at every point, E bar and dA bar are parallel. Therefore, the flux would be integral mod E mod dA cos 0. This would be mod E integral dA bar mod. What is the difference between integral dA bar and integral mod dA bar? What do you think it is? Again, we are talking about for sphere. If I don't keep mod, what happens? What is integral dA bar and what is integral mod dA bar? This would be 0. This would be 4 pi r square. Because the moment you say dA bar, you're talking about vectors, and all are you're adding vectors now. They're like spikes. All of them will cancel out. When you say mod dA bar, you're just adding the magnitude of that area. I hope you're getting the difference. Putting that mod makes a big difference. This is area magnitude. So for each small pieces, you're adding them. So you'll get 4 pi r square. This is a vector integration. Direction would matter and they'll all cancel out. Clear? So that's the reason it is important you write mod dA there. So this is kq by r square and 4 pi r square. So we get flux is q by epsilon. Great. That means we proved if you have a charge q at the center, the flux passing through this is q by epsilon. That means if I go and bring a random surface like this, an amoeba, the flux passing through that amoeba is equal to flux passing through the sphere, since the number of lines are same. That means it doesn't matter where you keep the charge, as long as the charge is inside, the flux is always q by epsilon. Isn't it? So this is some random closed surface, random closed surface. It should be closed. So flux through any closed surface. So we proved it for a sphere, and then we use the argument that the number of lines are same, and therefore we can say the flux is same. You're getting, I know how to find for the sphere, so I'm saying it is the same for everyone. Is q enclosed by epsilon. So we're actually proving Gauss law using Coulomb's law. But if you see the the time chronology, Gauss law came first and then came Coulomb's law. So this is the proof, since number of lines are same. So that is what you're using in Gauss law. The flux is equal to charge enclosed by epsilon, charge enclosed by epsilon. So what happens if the charge is outside? So for this thing, the answer is straightforward. Doesn't matter where you keep it. All clear with this page? Now see, what happens if you keep it outside? So if you have a closed surface here, now listen carefully, this is important. They can ask a good multiple choice questions. This is plus q. Every line that enters will leave. Therefore, flux due to outside charges is 0. Simple reasoning. If 2 are coming in and 2 are going out, flux is 0. Make sense? But let me ask you this thing. Exam, they won't ask you this. Exam, they'll say like this. Flux on the total surface, right, due to outside charges is 0. Okay. If they ask you like this thing, flux at any point on the surface, is it 0? Or they'll ask you like this thing, flux at any point on the surface is positive, negative, 0, which is true. a charge q is placed outside, the flux at any point on the surface is positive, negative, or zero, which is true.
No, sir.
Look at this thing. If you look at here, this is the area vector. Here the angle is acute. So flux at this small region is positive. If you look at here, this is the area vector. And this is your field. And if here look at the angle, this angle is obtuse. So basically the lines when they're entering, the flux is negative. The lines when they're leaving, flux is positive. And interestingly, there is one specific few regions here when the field line becomes tangent. Here the area vector will become perpendicular. The flux is zero, isn't it? So remember this thing. So flux determinant can be zero, can be positive, can be negative, but total is always zero. So don't get confused between the words flux at a point and flux total. So exam they'll ask this question. A charge q is placed outside. Flux at a point is what? Without thinking, people will write zero and come. So flux at a point and flux on the total surface are completely different. Clear with that? So there are some specific points, where the field line becomes tangent, you'll get a zero flux. Clear? There. So next class when we meet, we'll do a few more problems on flux calculation, right? And then we will be doing the Gauss law. We have some pretty nice questions, and especially we will see we have a lot of discussion on conductors. That is the most critical one actually. It's more confusing and more theoretical. So that is what we should focus more on. We will see that. Okay, so with that, we'll wrap up for the day. So any doubts in today's class, anything to ask me? And do make sure to try the homework problem that I gave. We'll discuss that in the next class.